In this video, we're going to be talking about covalent nomenclature, or how we name different covalent compounds. So, our rules and everything when naming covalent compounds or our nonmetals is that we are going to use prefixes in order to indicate the number of atoms. We are going to keep the first element's name, but we are going to change the second element's ending to IDE. So, our prefixes that we are going to be able to use, we have mono for 1, di for 2, tri for 3, tetra for 4, penta for 5, hexa for 6, hepta for 7, octa for 8, nona for 9, and deca for 10. Now, when we are looking at our different prefixes, we do need to have these memorized so that we are able to use them consistently throughout this unit. Now, one of the big things to note is that we are never going to use the prefix mono on the first element. So our different examples that we have CO2. So we have one carbon and two oxygens. So this and everything would be written as carbon dioxide. So even though we have a single carbon, because it is the first element and we only have one, we are not going to use the prefix mono. Mono will only be used for the second element. Our next example is our N2O5. So we have two nitrogens and five oxygens. So our two nitrogens would be dinitrogen, and then our five oxygens, five, we are going to use the prefix penta, and then our oxygen, we are going to change to oxide, so that IDE at the end. And then our third one is going to be our PCl3. So we have one phosphorus and we have three chlorines. So again, we are never going to use mono on the first element. So we're just using phosphorus in order to show that we have one phosphorus atom. And then we have three of our chlorines using the prefix tri. And then our chlorine will be changed to chloride. So we get phosphorus trichloride as the name. Now, going in the opposite direction, we're able to do the same thing. So we have dihydrogen monoxide. So dihydrogen is telling us that we have two hydrogen atoms. Monoxide, mono being one, our oxide being the oxygen, one oxygen atom. So dihydrogen monoxide would be H2O. Next, we have carbon tetrachloride. So carbon, we do not have a prefix out front, so we assume that it is one. So we have one carbon atom, and then we have tetrachloride. Tetra being four, and our chloride being our chlorine. So we get carbon tetrachloride being CCl4. Let's go ahead and take a look at a few examples. So our first one that we have is our CO. So we want to go ahead and name this compound. So we have one carbon atom, we have one oxygen atom. So we know that with one carbon atom out front, we're going to want to keep this without a prefix. So this will just be our carbon. And then our oxygen, we have one of. Now we do use the prefix mono for the second element. So we get our mono, and then our oxygen. We change the last little part to our IDE. So in this case, we changed our Y, G, and N to the IDE. So we get oxide. Now, we don't want to have a double O next to each other. So it's our MONOXIDE for our carbon monoxide. And there it is written just a little bit better. So carbon monoxide. Let's take a look at our CO2. So in this case, we have one carbon atom out front. Now, we do not use the prefix mono on the first element, so we just get to keep this as carbon. Now our O2, we have two of the oxygen atoms. So the prefix that we are going to use is going to be our di. Now our oxygen becomes our oxide, so we get dioxide as the name. So our carbon dioxide. Let's take a look at our N2O, our next one. So in this case, we have two nitrogen atoms, one oxygen atom. Now, we have two nitrogen atoms, so we do get to use a prefix, so we get our di, and then nitrogen stays the same. And then we have our oxygen, and we have one of them. So this is our mono. And then our oxygen becomes oxide. So we get dinitrogen monoxide as the name of this compound. Let's take a look at our NO2. We have one nitrogen atom, so we do not use a prefix. So this is nitrogen. And then we have our O2. So we have two oxygen atoms. So the prefix that we use will be di. Oxygen becomes oxide, so nitrogen dioxide will be the name. Let's take a look at one a little bit more complicated. Let's take a look at our N2O5. So we have our two nitrogen atoms, we have five oxygen atoms. So starting with the nitrogen, we have two of them, so we get our dinitrogen. And then we have our O5. The prefix for 5 will be our penta. But we're going to keep it as pent for the moment because our oxygen becomes our oxide. So in this case, our A at the end of the penta is going to be dropped because then we're going to have our oxide afterwards. So this is pentoxide, not pentaoxide. And these are just going to be some of the slight naming rules that we just have to get accustomed to. So we are going to end up with our dinitrogen pentoxide as the name of this compound. Let's take a look at another one. So we have our SO2. So kind of moving away from our nitrogen, we have our single sulfur atom, and we have two oxygen atoms. So single sulfur, we do not use a prefix, so this is our just sulfur. And then our O2, two oxygen atoms using the prefix di. So we end up with dioxide. And we get sulfur dioxide as the name of this compound. Let's take a look at our SO3. So again, we have a single sulfur atom, so we do not use a prefix. So we have sulfur, and then we have our O3, so three oxygen atoms. Now, remembering that the prefix for 3 will be tri, and then we have oxygen, which will be changed to oxide. So trioxide will denote our three oxygen atoms. And so we end up with sulfur trioxide as the name. Let's take a look at our BRF3. So a little bit more of a different type of compound. Let's go ahead and take our Br, so our bromine. This and everything is going to be one bromine atom, but we do not use the prefix mono for it, so we just used bromine. And then we have our F3. So we have three of the fluorine atoms. So the prefix that we use will be tri. And then our fluorine will be changed to fluoride. So fluorine being changed to fluoride. So we get bromine trifluoride as the name. Let's take a look at our next example. So we have ICl5. So our I will be iodine. I only have one atom of the iodine, so I do not use a prefix. So we have iodine. And then we have Cl5. So we have 5 chlorine atoms. Our prefix for 5 will be penta. And then our chlorine will be changed to chloride. So we get pentachloride. And so all together, we get iodine pentachloride as the name. Let's take a look at another example. Take a look at our XeF4. We only have one xenon atom while we have 4 of the fluorine atoms. So one xenon, so we just get to write xenon for this. Now our F4, so 4, the prefix that we're going to use is going to be tetra. And then our fluorine becomes fluoride. So tetrafluoride will be the name of the second element. And so we get xenon tetrafluoride as the name. Now, for our next few examples, let's go ahead and do the opposite. We're going to go from the name to the formula. So in this first one, we have dinitrogen monoxide. So our di will mean 2. We have nitrogen being our N, nitrogen. Now, monoxide. Our mono means 1. And then the oxide will be oxygen. So I have 2 nitrogens and 1 oxygen. Now, whenever writing out the formula, those numbers are going to become our subscripts. Those are going to show the number of atoms that we have. And so we're going to end up writing it as N2O. So I have 2 nitrogen atoms and I only have 1 oxygen. Now, when writing this, if I do not have a subscript, that means that I only have 1 of them. So our N2O. Let's take a look at dinitrogen tetroxide. So dinitrogen, so di being 2, nitrogen being our N, our tet, which will be tetra, will mean 4, and then oxide being the oxygen. So 2 nitrogen atoms, 4 oxygen atoms. And so we're going to write this as our N2O4. So 2 nitrogens and 4 oxygens. Taking a look at our sulfur dioxide. Now with this one, I do not have a prefix out front. So I assume that this is 1. So I have 1 sulfur atom. Now dioxide, di meaning 2, oxide being oxygen. So I have 1 sulfur atom, 2 oxygen atoms. And so we're going to write this as our SO2. 1 sulfur, 2 oxygen. Let's take a look at our phosphorus trichloride. Again, we do not have a prefix out front, so this means that we have 1 of them. So 1 phosphorus atom, then trichloride, tri being 3, our chloride being our chlorine, our Cl. So 1 phosphorus atom, 3 chlorine atoms. Putting that together, I get PCl3. 1 phosphorus, 3 chlorine. Taking a look at carbon tetrachloride. Again, I do not have a prefix out front, so I assume this is 1. So 1 carbon atom, tetrachloride, tetra being 4, chloride being chlorine. I have 1 carbon atom, 4 chlorine atoms. Putting all this together, I get CCl4. 1 carbon, 4 of my chlorines. Let's take a look at our silicon dioxide. So I do not have a prefix out front. I assume this is 1. So 1 silicon atom, dioxide, di meaning 2, oxide being our oxygen. So 1 silicon atom, 2 oxygen atoms. Putting this together, I get my SiO2 as the formula for this. Looking at our bromine trifluoride, again, no prefix out front. I assume this is 1. Our bromine symbol is our Br. So 1 bromine atom, trifluoride, tri being 3, fluoride being our fluorine, Rf. So 1 bromine atom, 3 fluorine atoms. Putting all this together, I get BrF3. Taking a look at our iodine pentafluoride. No prefix out front. I assume it is 1. So 1 iodine atom. Now our penta, this and everything is our prefix for 5. And then our fluoride, being the fluorine, will be our F. So 1 iodine atom, 5 fluorine atoms. Putting all that together, I get IF5. And that is going to be how we take a look at our covalent naming. Now, just kind of as a reminder for this is that remember that all these different compounds that we're going to give you are going to be based off of the IUPAC naming system. And so that and everything is definitely important to remember because there are common names for these different compounds as well. And that can be seen with our H2O. So H2O can be our dihydrogen monoxide, but we and everything will typically reference that as water. So whenever we're looking at these, is that we're wanting the IUPAC naming system, not the common name of them.